Okay, let's look at graphing the cosine function. So let's figure out what each part of the cosine function does. So we have our a value. This again is our amplitude, which is the absolute value of a. You have our vertical stretch, our vertical compression, and we have our vertical reflection, in the x-axis when we have a negative. We can calculate the amplitude by doing the max minus the min divided by 2. This is our trig function. Our b value is our horizontal stretch, our horizontal compression, or we can get a horizontal reflection in the y-axis if there's a negative in front. H is our phase shift, left or right. And K is our vertical translation, up and down. It's our midline. I can calculate K by doing the max plus the min divided by 2. This will give me the midline of my graph. The period can either be calculated by doing 360 divided by b if you have a sine or cosine graph, or the period is 180 divided by b if you have a tan graph. So let's look at graphing the cosine graph. So my base function will be y is equal to CosX. My values, key values, are 0, 90, 180, 270, and 360. That doesn't change. My cosine graph, however, starts at 1, goes to 0, minus 1, 0, and 1. So now we're looking at these are different numbers for my y values. You're going to have to learn the difference between the two. Now I want to look at my x and my y and what's happening to my transformations. So I have my x, that's anything inside the bracket, and they lie. Y is anything outside the bracket, and it does what it's supposed to do. So if I look at x, it says a half. You would think that we're going to divide by 2, but we're not. We're going to multiply by 2. This says plus 90, so instead of moving right, we're actually going to move left, and we're going to subtract 90. The brackets lied to us. For our y, we're going to multiply by 3 and subtract 2. So if I do times 2 and subtract 90 to all my x values, I'm going to get minus 90. I'm going to get 90 times 2 and subtract, I get 270. Times 2 and subtract, I get 450. And then I get 630. Then if I look at my y values, times it by 3 and subtract 2 to everything, my 1's will stay the same. My 0's become minus 2. And this becomes minus 5. So let's go and graph these. Remember, we're going up by 30s. So this is minus 90. I'm going to go to 1. At 90, I'm at minus 2. At 270, I'm at minus 5. Back up to 2, sorry, minus 2. And at 630, I'm up to 1. So this has basically a sine graph and a cosine graph are the same graph, they just start in different places. That's why they're both called sinusoidal functions. This is going to continue down like this, and this will continue down like that. If we want, we can highlight the cycle in our table, and then everything else is continuing the pattern. Okay, let's try another one. So I want to do the base graph of y is equal to cos x. I have 0, 90, 180, 270, 360. My cos starts at 1, 0, minus 1, 0, 1. Okay, we do need to know the difference between our sine graph and our cosine graph and where they start. And again, let's look at what we're doing. So my x is anything inside my brackets. And my y is anything outside my brackets. So it says 3, which means I'm going to divide by 3, and I'm going to add 150. This means I'm going to divide by negative 2 and add 1. So if I divide all of these by 3 and add 150, I'm going to get 150, 180, 210, 240, and 270. I'm going to take all of these, divide by negative 2, and add 1. So this becomes 0.5, and so does this one. My 1s are both 1, and this becomes 1.5. So now I can graph this. So there's 150 and 0.5, and 1, 1.5. So it's a nice little tiny one. Okay, so there's my original cycle. And now I'm going to map it out. I'm going to keep following the pattern. And I'm going to connect them. Make sure you go right through them and that they're rounded. All the way to the end. Okay, we're going to go backwards, and we're going to go the other way. We're going to pattern to the end.